In this video, I'm going to introduce you to the graphs of sine and cosine functions. The first thing we're going to do is make a t-table, and we're going to look at the sine function first. And remember that the value of sine, when we're looking at the unit circle, is the value of y at the terminal point where that angle swings open. Now, because we're going to be graphing this on a grid, I want to put the values in approximate form in decimal form, basically, so that we can graph this a little bit easier than trying to figure out the square root of 3 over 2 is on the graph. We're going to be using radians for our table. And when we swing open 0 radians, if I look at the y value at 0 radians for the terminal point, I'm going to get 0. And then I'm just going to continue to make my table by looking at the unit circle. I'm going to swing open to pi over 6, and I'm going to look at the terminal point for pi over 6, and I'm going to look at the y value of that terminal point at pi over 6, and that would be 1/2, which is 0.5. Then I'm going to look at the terminal point when I swing open to pi over 4 and look at the y value of that terminal point. And that gives me the square root of 2 over 2, which is approximately 0.71 in decimal form. And I'm going to go ahead and do this all the way around the circle for each of these radians. I'm going to sweep open, look at the terminal point, and look at the y value of that terminal point because we are trying to make a table for sine. So I'm going to go ahead and finish filling out this chart. At pi over 3, that would be the square root of 3 over 2, which is approximately 0.87. At pi over 2, we would have 1. At 2 pi over 3, we would have 0.87. At 3 pi over 4, it would be 0.71. At 5 pi over 6, it would be 1/2. And then at pi, it would be 0. At 7 pi over 6, it will be negative 0.5. Then at 5 pi over 4, it would be negative 0.71. And at 4 pi over 3, it would be negative square root of 3 over 2, which would be negative 0.87. And then at 3 pi over 2, it would be negative 1. 5 pi over 3 would be negative 0.87. 7 pi over 4, which would be negative 0.71. 11 pi over 6, which would be negative 0.5. And then at 2 pi, back to 0 again. So now let's look at the major features of the graph based on our table. So the x-intercepts are the value of x when y is 0. So in this case, we're looking at the x-axis, which is our value for theta, and our y-axis is our ratio. So we're looking to see what are the angles where the value of our ratio is 0. We would have 0 radians, we would have pi, and then 2 pi. Now, if we continued the cycle and we went through another rotation, or if we went counterclockwise a rotation, if you notice, this is going to keep repeating because we've completed a circle, and then when we start the next rotation, the y values or our ratios are going to continue to repeat. So that means any multiple of pi is going to be an x-intercept. It's going to be where it crosses the x-axis. And we would write this as k pi, where k is in the set of integers. The boldface Z represents integers. This symbol here means in the set of, and then of course k is this k in front of the pi. So by saying that k can be any integer, that's saying any multiple of pi. So it could be 2 pi, 3 pi, negative 2 pi, negative 5 pi. This k could be any integer. The y-intercept is only going to happen in one place since this is a function, and that is going to be at the point 0, 0. For the graphs of sine and cosine, we don't have any asymptotes. We will later when we get into some of the other functions. And the period is 2 pi because that's when our values start to repeat. The amplitude is how high it comes up from the midline. And the midline is just when we graph the original sine function, the midline comes up along the x-axis. That's the center of our graph. It's a horizontal line that cuts the graph in half. And so if I come up from that midline, up as high as the graph goes or as low as the graph goes, that's our amplitude. And in this case, the highest it goes, and you can see this in our table, the highest it goes is 1, and the lowest it goes is -1. So I would say that our amplitude is 1. And from previous sections, we know that sine is an odd function, which means if I plug in -x, and for sine, or a negative angle, it's going to be the same thing as switching the output of that function value. Now let's go ahead and actually plot these points. So using the table that we did above, I'm going to plot the points. So we have 0, 0. At pi over 4, we had 0.71. At pi over 2, we had 1. Then at 3 pi over 4, we had 0.71 again. At pi, I had 0 because that was an x-intercept. At 5 pi over 4, we had negative 0.71. At 3 pi over 2, I had -1. At 7 pi over 4, I had negative 0.71. And then at 2 pi, we had an x-intercept again. So this is one cycle of the sine function. Here's the midline. The midline is what goes down the center and cuts the graph in half. So in red, this is the midline. So our maximum is going to be at 1, and our minimum is going to be at -1. So our amplitude in this case is 1, because from the midline up, that's the furthest it comes out from the midline. Now, if I continued this cycle, I would get a picture that looks like this. If I continued the picture, and it goes on forever in either direction. This in green, however, is the first cycle, the first period. And that is what we're going to use later when we start translating the graph and when we start shifting it and moving it around or squishing it in or compressing it or stretching it. We're going to be using the key points of that first cycle. And for the sine function, our key points are going to be at 0 radians, we have a ratio of 0. That's a key point because it's an x-intercept. We also have another endpoint. We're going to do the starting point, the end point, the midpoint, and then the max and the min. So here we would do where it ends for the first cycle, which would be at 2 pi, we would have 0 again. Then we would do the midpoint, which would be at pi 0. And then we would do the max and the min. These are our key points for the first cycle. And so for the max, we would have at pi over 2, we would have 1. And for the min, we would have at 3 pi over 2, we would have -1. So these are going to be our key points when we start graph shifting the sine function. So now we're going to do the same thing for cosine of theta to make a t-table. So we're going to swing out a certain number of radians given in the table. Then we're going to look at the terminal point. And when we look at the terminal point, now we're going to be looking at the x-coordinate of that terminal point, since cosine represents the x value of the terminal point. So when I swing open 0 radians and I look at that terminal point, and I look at the x value of the terminal point, that would give me 1. At pi over 6, that would give me the square root of 3 over 2, which is approximately 0.87. Then at pi over 4, that's going to be approximately 0.71, which is the square root of 2 over 2. At pi over 3, we get a half. At pi over 2, my x value at that terminal point is 0. At 2 pi over 3, that's negative 0.5. At 3 pi over 4, that's negative 0.71. At 5 pi over 6, that is negative 0.87. And at pi, that's a negative 1. Then if I come out to 7 pi over 6 and swing open and look at the x-coordinate of my terminal point, that's going to be negative square root of 3 over 2, which is negative 0.87 approximately. Then we're going to get negative 0.71. At 4 pi over 3, it's negative a half. At 3 pi over 2, that's where x is 0 at the terminal point when we swing open at 3 pi over 2. At 5 pi over 3, it's positive 5, or positive 0.5, then positive 0.71, then positive 0.87, and then at 2 pi, we close out the loop, and we've made a complete rotation, and we finish at 1. Now, when we look at the x-intercepts, that's when our y value is 0. And in this case, our y is our ratio. So think of this as x and this is y. So for our x-intercepts for cosine, we're going to have, for the first rotation, at pi over 2, then at 3 pi over 2. If we continue the cycle and we keep going around and do a second rotation, and we keep adding 2 pi to these or subtracting 2 pi's to get all the x-intercepts that are possible, it would be k pi over 2, where k is in the set of odd integers. Because notice that my multiples in front of the pi here are odd. And if I continue and do that for each rotation, the next one would be at 5 pi over 2, then 7 pi over 2. And then I could go in the other direction as well and do minus pi over 2, minus 3 pi over 2. So my value of k here is going to be odd integers. Any multiple of pi over 2 where k is an odd number. If k was an even number, so let's say, for example, we put in 4 for k, that would be 4 pi over 2, which is 2 pi. And if you look at 2 pi, that's not an x-intercept. That gives me a value of 1, not 0. So it specifically has to be for odd integers. Now the y-intercept here, it's going to cross, if you notice, at 0, 1 on the y-axis. And again, for sine and cosine, there are no asymptotes, but we'll get into that later for some other trig functions. The period for cosine where it starts to repeat is 2 pi. So once we go through that full unit circle through 2 pi, then the values or the ratios start to repeat. For cosine, the amplitude is going to be a 1 again. So if you look at your midline, the x-axis in this case, before we start shifting it, it goes up 1 and down 1 from the midline to get to that max and that min. And then the last thing, if you recall, cosine is one of the two trig functions that are even. That means cosine of negative x is the same as cosine of positive x. Now, if I use my table and I start plotting points to come up with our first cycle, x0 we have 1. At pi over 4 we have about 0.71. At pi over 2 it's 0. At 3 pi over 4 it's about negative 0.71. Then at pi it's at negative 1. Then I come back up to 0.71. At 3 pi over 2 it's 0. 7 pi over 2 I come back up to about 0.71. And then at 2 pi we complete the cycle and it comes back to 1. So this is our first period or our first cycle for cosine. Here's our midline. It's the x-axis that comes up through the center. So the midline is going to be the graph of, so the midline will be the line y is equal to 0. So the amplitude, if you notice, you come up from the midline a maximum of 1 and you come down a maximum of negative 1. So our amplitude is 1. Now if I continue the cycle, it's going to look like this. And it's just going to keep going forever. However, this is our first cycle here, and this is what we're going to use when we graph translated functions. So the key points for cosine that we're going to use, our starting point, which is at 0, 1, then our end point, which is at 2 pi 1, then our midpoint would be at the point pi negative 1, and then we have our x-intercepts at pi over 2 and at 3 pi over 2. So these are going to be the key points that we use when we start doing our translated cosine functions.